Hello, everyone. My name is Riley Dickens, and I'm a consultant at Encryption Consulting. Encryption Consulting covers all the aspects of security concerns, such as data security, key management, and data privacy. Our video today will take a look at Google Cloud Platform's encryption of data in transit. First, we'll begin with the introduction. Google Cloud Platform, or GCP, is one of the leading cloud service providers in the market. With a massive number of customers, Google takes data protection very seriously. Google encrypts data by default at multiple layers, and it lets its customers enhance or manually control the encryption process. Google performs data encryption both at rest and in transit. In this video, our focus will mainly be on encryption of data in transit. For data in transit encryption, Google uses an open source implementation of the TLS protocol called Boring SSL to secure the transport layer and ensure authenticity, integrity, and privacy of data. Google's security mechanisms are implemented based on traffic and data transit routes. We'll take a look at a few different scenarios in the upcoming section. All inbound requests to any Google Cloud service are always routed through a globally distributed system called the Google Frontend, or GFE. GFE is a very sophisticated system and has many different features. It terminates traffic for incoming HTTP, HTTPS, TCP, and TLS proxy traffic, provides DDoS attack countermeasures, and also routes and load balances traffic to the Google Cloud services themselves. By default, GFE ensures authenticity, integrity, and data privacy by verifying the sources of the data, and then making sure that the data is sent unaltered to its destination. Finally, all incoming data is encrypted using Transport Layer Security, or TLS. Now let's consider another scenario where data in the Google Cloud may move from one service to another based on its requirements. In certain situations, a third party might also be present in between, but we'll discuss this situation later on. Now, if the data remains within the boundaries of Google, then it is authenticated, but not necessarily encrypted, since Google has rigorous security controls already in place within its boundaries. For scenarios where data moves from a Google Cloud service to a non-Google network, encryption is performed in the network layer. Google Cloud's virtual network infrastructure encrypts VM-to-VM traffic every time a physical boundary not controlled by Google is crossed. The communicating hosts first perform a handshake and, if acknowledged, encrypt data using AES 128. All data in transit at the transport layer is authenticated. This protects a compromised host from spoofing packets on the network. When the application layer data is encrypted, Google's infrastructure provides authentication, integrity, and encryption of remote procedure calls, or RPIs, from service to service when those calls leave a physical boundary controlled by Google. Just like before, this also has a handshake protocol, and data is encrypted using AES 128. Google is an industry leader in encryption in transit, and it is constantly enhancing its capabilities and innovating in this domain. The next generation of in-transit data protection is moving towards key transparency and post-quantum cryptography. Google always ensures all data that routes through it checks three parameters: authenticity, integrity, and privacy. Google performs encryption of data in transit by default. However, it also enables users to implement further protections with tools such as IPsec tunnels, Gmail SMIME, managed SSL certificates, and Istio. Google also provides multiple open source projects for encryption in transit that can be utilized by other parties. These services include certificate transparency, Chrome APIs, secure SMTP, and more. This concludes our video for today. Thank you for watching. If you liked it, please leave a like and subscribe below. Contact us at encryptionconsulting.com if any confusion arises, or if you simply want more details. Thank you.